Hi guys, this is Syed from Hyderabad, India. So in this quick video, I'm going to walk through the process of setting up VS Code for the ESP32-C3 and flashing the device. So Espressive recently launched a new family, the ESP32-C3, which is a single core device with Bluetooth and Wi-Fi, and very interestingly, it has RISC-V at the core. Now this is a very interesting offering. They are moving over from their popular Extensa platform family over to the RISC-V, which is interesting in a couple of ways, but then there is a lot of support to be added in the future, which is rudimentary at this point. So these guys released or asked for developers to apply for a beta program to test out the ESP32-C3 chipset around December, and I applied as well, and I was lucky enough to receive the ESP32-C3 dev kit M1, which is something like this. They have given out these devices to hundreds of developers across the world, and they have been posting all their Hello World programs and stuff. Now the reason for this video is to introduce how we can use VS Code to flash this particular ESP32-C3 variant. I recently came across the Espressive that was my email. So I just came across this very amazing video by Espressive where they were walking us through the process of using the ESP-IDF Plugin for VS Code, wherein it automatically installs the whole SDK, the tool, sets up the environment, and allows you to directly flash from within the VS Code IDE. Now this is different than the Platform IO IDE extension. This Espressive plugin specifically allows us to play with the ESP-IDF directly. I thought this was pretty interesting, and the moment I received my ESP32-C3 2 days back, I thought, man, I should really try out this VS Code plugin on VS Code plugin and try to flash my Espressive ESP32-C3 dev board. The board comes with a pre-installed Rainmaker firmware, which allows us to directly provision it from our Android or iPhone devices and start tinkering with it right away. They have a very interesting offering called as the ESP Rainmaker, which allows you to directly push devices without having to worry much about the backend architecture or managing the cloud and stuff. They provision it through their AWS integration and stuff. So pretty interesting stuff out there. So I'm gonna let's walk through the process of setting up the VS Code. This is a quick hack or a hardcore kind of stuff. Not good, but it works. I really spent around one day, a couple of hours trying to figure out this stuff, but it wouldn't work on my 32-C3, so I was really frustrated. And then eventually there was a eureka moment, and I thought, why don't I hardcode the values and see if it works out, and it did. So I thought I'm going to share this with folks who are interested in trying this out, and here we go. So I really would recommend that you have followed this video. The link, I'm going to share it in the description of the video. First, make sure that you have the VS Code completely set up. You have a Hello World program blinking for the ESP32 version. Now the drawback of the VS Code, not drawback, the limitation yet, the VS Code for Espressive currently supports compilation, flashing, debugging, etc. for only the ESP32 and the ESP32S2 family. It doesn't yet support ESP32-C3, which is what we are going to get support for now in this particular video. So if you can see, there was mention of it somewhere, somewhere over here. Yeah, so here it is. So they have no support for 32-C3 yet, but this quick hack will make it compatible now. Assuming you have followed the entire video over here and have a proper working ESP-IDF setup inside VS Code, let's open VS Code and modify the target.CMake file. My PC is pretty slow, so excuse me, bear with me while this loads. Let's navigate to this particular folder, which is, oh my god, my PC is really stuck up. So if you have your ESP-IDF installed to a particular path, open it up, you will find a folder called tools. Inside the ESP-IDF folder, open up the tools folder, you will see the CMake folder. Inside it have a file called as targets.cmake. Yeah, this is the file. Now you have to open this file and hardcode it with the value ESP32-C3. For more better clarity, I'm going to show this in the VS Code itself. So this particular thing which you see, these 3 changes, is hard-coded by me for making this whole setup or environment compatible with ESP32-C3. Now if I show that to you in a comparison video, in a diff video, you will see the original file as this. This is the original file. You would have the environment IDF target setup as the environment variable, which is IDF underscore target. We are gonna replace this with ESP32-C3. We have to replace it thrice in these 3 locations, and I am gonna share a link to this CMake file, and so you can directly copy paste and replace in your setup environment. And you would also have to comment out this if condition, and that's it. Once that is done, you can now compile the example codes that support ESP32-C3 and flash it directly from your VS Code platform. So let me show that to you live. We're gonna open up the examples from the ESP-IDF examples. Okay, ESP-IDF show examples project. It's gonna pop up and ask for the EDF. Select the current EDF. Oh, sorry, IDF, and let's select the Hello World program. And mind you, the Blink example won't directly work because the GPIO 8 in the ESP32-C3 is actually a WS2812B NeoPixel LED. So your typical Blink Hello World won't work. But for the sake of understanding, I'm going to simply run the Hello World program that simply outputs some information of the IC and a message. You have to really bear with me. So this is pretty slow. I need to upgrade my PC real bad. Now let's navigate to the getting started with programs. Where is it? I think it went up. Oh my god, it went up. Here we go. So let's go slow. Get started, Hello World program, and let's say create project using Hello World. Select a directory. I'm gonna say F drive somewhere in your PC. Alright, select folder. And it should open up the workspace. It is supposed to open. I'm not sure. I don't know why it isn't opening. Is it because I have to close the workspace, or no, I have to change over the workspace? It's still in the same workspace. It's not opening the Hello World program. I'm going to select F drive and hit select folder and create. Now I am not sure what's going on. It could be that my system, right, error copying ESP-IDF example. Why is there an error? I don't know. I'm gonna retry this. I'm gonna select a different folder. Let's select my D drive and say, right, now let's hope this bugger opens up. Okay, I see something happening. Wow. Woo. So it opened up. damn it, I have some existing SD config in my D drive, so this is showing up the previous stuff. Let me clear out the build directory and make it fresh. You would not I'm not sure if the SD config is supposed to be shown over here. It is actually generated when we run the CMake and stuff, so I'm deleting it. Let's see our code real quick if that is our intended code. Alright, fine. Shit, I actually messed up this code. So what I'm gonna do, this is a different code and this has some bugs because I was trying to play around with the WS2812B. Let me quickly put this into some other weird location. Show examples project, and let's go and put it somewhere really strange so it doesn't cause any error. Where are we? Where is the hello world program? Get started, hello world, and create project. And now let's select T drive and okay, yeah, so see the hello world program is already there. I would not go there, I would say drive. I do R&D, so let's select R&D. I hope this opens up now because it's been some time and you guys must be getting vexed up as to when the hell is this really gonna happen. So this is due to my PC being damn slow. I have to upgrade to a better machine, but I can't till it takes some time. Please God, let it happen. Ooh, it's happening. Wow. Why is it still showing the... Oh! I really went and messed up the ESP32 source code in the examples thing, and for that reason this is with this thing. So I'm really sorry for this time wasted here. I'm gonna go back. I'm gonna actually trim out this video, and you might probably not have to see this whole mess again. F1. Let's go to ESP show examples project, and let's use the same thing. Let's use the blink example because now this is a little embarrassing for me because the examples template is fetched from the ESP-IDF folder, which I went and manually messed up before I went over to VS Code, and this is causing all these issues. So blink project, let's open this up in somewhere in say R&D and call it select folder, and let's hope it opens up. This video should not become so long. I really don't want to become really long, then it becomes irritating because this is like a 3-minute 4-minute hack. I have also given out a link to a small tutorial with screenshots of this process, so you can use that directly step through the video and get it done. Fine, we have the blink stuff with us. Let's hope this is not messed up. Alright, basic free hours task creation. I'm gonna simply remove the existing SD config. I'm actually gonna, the better ways to clean the build. Blah 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 blah. Fine. Bugger off. Alright, this is because of some crap issue. With that being said, with our target of CMake properly set, let's go and flash no, first build the projector. Now let's say woo and wait. Alright, there we go. CMake. Now this is gonna take maybe 2 to 3 minutes. I have some cold, so you should really excuse me. This is not so slow. Could probably be because of me running so many stuff in the background. Actually nothing, but the OBS recording studio could be really RAM intensive, so I'm not sure. It's not this slow, but who knows. This bugger could be the cause of the RAM being eaten up. Come on. Oh, I don't really know. Can we pause this thing? I hope I am recording. Yeah, not bad. This is actually my first recording after many years, so I hope it goes good. Come on, expressive. Wee! Something we see. This should not take more than 45-60 seconds on a decent machine, because I am using a bugger. This is so slow. I have 4 gig RAM only, and some stupid quad core Intel blah blah blah. Oh, good. So this is interesting, because otherwise you'll always see ESP32-C3 or S2 or ESP32 only. Now this is a good indication that we are on the right track. Notice that it is picking up the compiler properly, the RISC-V ESP-IDF folder. That's good news. Fine, not bad. And the SD config is generated, and you would now see the SD config pop up over here. Yep, it popped up, and it would now have ESP32-C3 inside it. Yes, we have it. Now here we go. This will take maybe a minute to 2, but I'm gonna make sure I see through this entire thing, so you guys can step out, pause, take a break, grab a cup of coffee or tea, and come back in 3 or 4 minutes. So, because this is really gonna take time, especially on my PC. So meanwhile, it's 11:33 IST in India, where I'm based out of. I just went to an awesome wedding party and came, and I think my brains are all running up because of the awesome delicious food I had. Wow. Good. Yeah, 1 out of 956. Now let's see this through. While this happens, I would maybe ramble around. I'm not sure if platform Mu, that's how they wanted to be pronounced, platform Mu has released an update for including the ESP32-C3 toolchain. I'm not sure if that is yet out there. The last I checked 3 or 4 days back, they didn't have anything out there. And this is pretty interesting to use ESP-IDF inside VS Code. The earlier IDE which was supported was Eclipse, but then the recent the VS Code plugin is actually a couple of years old. I think it's around a year or 2 year old here. But then the recent video which they launched was really helpful. This is a very interesting video. very politely. The author, I don't know who the author is, he has really done a very good job of explaining it in such a nice way, with such an awesome melodious voice, and not rant and fumble like I am doing over here. Oopsie. Fine, so this is 10% here and then 90% to go while this happens. So I haven't yet tried out debugging and stuff because I don't have a JTAG adapter, but if I read the docs, I think it said sorry, the dev versions does not support JTAG debugging yet, I think. Yep, they sent out a quick start note along with the dev kit, and if I remember, it said that it does not support JTAG debugging yet. That's interesting. It's 15%, a couple of more time to go, maybe 5 or 6 minutes. I would really fast forward this video snippet so you don't have to worry about me rambling and blabbering. BRB. Many users actually received I think the other version, the devkit C1, which is compatible, pin to pin compatible, at least with the Vroom ESP8266 offering. I'm not sure why I received the devkit M1, which is actually good in a way because it's so cute and small and petite. VS Code was released at least 1 year or more than a year. Many Twitter users posted pictures of the 32C3 while this guy opened up. Anyways, what is this? Is hyperlink to the dev kit. I really love this new Espresso website. I don't know when they created, but it's pretty amazing. It's a pretty futuristic look on the website with DICs and stuff shown pretty amazingly. But dev, it's all 100% used up. Yuck. This is taking some time, as I said it would. This is actually taking more time because I'm not sure, is it because of the OBS Studio which is recording in the background, or because I haven't restarted for quite some time now. I don't care as long as it works, as long as you guys understand how to do it and enjoy VS Code for the ESP32-C3. Right, 36%, some more to go. You guys must be laughing at how damn slow my system is. Imagine working with such speed and churning out high impact projects. Wow. Come on, you bugger. Alright, 50%. I don't know, there seems to be some other module called as the DTBL10. Now, I don't know what that is. Is that also RISC-V based core? Seems to be quite compared with this one online, not sure. Alright, 61%. Right, 70%. I just hope my son doesn't come running out from inside. He is having his dinner, so it's pretty peaceful and calm out here. And that's my mom laughing in the background. That's my stupid nose. Yeah, seems the DTBL10 is made by the Buffalo Labs folks. BL602 RISC-V processor used with it. The model is BL602. I have to check it out while this happens. BL602. I would not check it out. I'll do it later. Why ruin the fun of ESP? Yeah, this is what I actually received. Other folks actually received this version, I think, but most of the folks on Twitter showed pictures of receiving this one. Now this is actually compatible with the Vroom ESP8266 pinout. Could be intended to be used as a drop-in replacement for that. Alright, so we are at 80% now. This is the dev board. This is good actually. Interesting. Where? Where are we with this? 91% almost completing. So this is good. This is worth the wait. Right, fingers crossed. I'm so excited that I'm not able to speak properly, because if it fails now or something out of the blue happens, it's not good. Alright, come on baby, come on. Man, 4 more steps to go. Come on. Please. Okay. Okay. Come on. Alright. So finally, that was worth the wait. I don't know how many minutes went away over there. And this is amazing. So we have the binary generated. Now let's flash it. Poof. Select the UART port. We are supposed to select the COM port earlier, which I have done already, and this is flashing right now, and it has flashed. So flash done, successful. Let's open up the terminal from within VS Code, and we should see it showing some boot messages and hello world and restarting in 9, 10, 8, 7, 6, 5, 4, blah 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 blah, and it keeps on rebooting. This is supposed to happen very fast, but my machine is really a bugger right now. So it's good that it's happening so I can see what script is running. Alright, there we have success. Turning off the LED, on off, on off. This is connected to some pin, I think it's for something, I don't know, but not bad, it's working. So let me kill this terminal. Let's quickly check from our PuTTY just to make sure it's really happening. We are on COM 13.11.52.00 and bugger, it's happening. Woo! Let me manually restart my device and alright, so this is happening. This was a quick not a quick, actually a very long demo of doing a 3-minute job in 30 minutes. A quick recap: go and change the targets.cmake file inside the CMake folder under tools, replace the ESP-IDF target with the ESP32-C3 stuff, comment out this part, and go compile. Have fun. If you guys have any questions, probably drop a comment, or better still, go and create or open issues or tickets on the GitHub page for VS Code, because I am pretty naive to this whole setup and I thought I would simply share what I know. Happy hacking. Thanks. See you around. Bye bye.